All right, here we go. Test review day. Find the solution set, then graph on a number line. Solve for x, but remember it's inequality. So there's a greater than sign, less than sign, greater than or equal to, less than or equal to. And you have to know what that means. All right, so let's solve for x. First things first, I'm going to subtract 4 from both sides. Cancel out right there, leaving me with just 3x. Does subtracting on both sides have any impact on this inequality symbol? No. Addition or subtraction has no impact. It's only multiplication or division on both sides. You have to be careful. Am I multiplying by a positive or multiplying or dividing by a positive, or multiplying or dividing by a negative? Okay, so that inequality is still greater than. 28 minus 4 would be 24. And now I need to solve for x by dividing both sides of the inequality by 3. That cancels out. And now I'm left with x. Dividing both sides by 3, that means it is still greater than. It has no impact because I divided both sides by a positive. And 24 divided by 3 is 8. So the solution set is x is allowed to be any real number as long as it is greater than 8. So I make my number line. I put 0 in the middle. I'm going to put 8 on the right. I'm going to circle 8, make it obvious. And then I'm going to shade all numbers bigger than 8. And at the end of my number line, a big fat arrow. And now I ask myself, is 8 itself included in the solution set? No. It has to be greater than or equal to for 8 to actually be legal to plug in. All right. Number 2. 6x minus 5 is less than or equal to 47. Let's see. Oh, hang on. That should be a negative. Sorry about that, guys. 6x minus 5 is less than or equal to negative 47. So what do we need to do? Well, we need to add 5 on both sides. And now, the 5 and the negative 5 cancel each other out. Addition on both sides of the inequality. The inequality symbol has no impact from addition on both sides. So I still get 6x is less than or equal to, that would be negative 42. Okay. And now I've got 6x is less than or equal to negative 42. And now I'm going to divide both sides by positive 6. Analyze the situation for me. What did I do? Well, x is isolated, but specifically negative 42 divided by positive 6. I had divided both sides by positive 6. That's still less than or equal to. It's what I apply on both sides. I don't care about that negative output. It's what I do on both sides. So that's x. Legally, you're allowed to be any real number as long as you are less than or equal to negative 7. Okay, so now let's graph it. I put 0 in the middle. Let's put negative 7 on the left. Circle. Make it obvious. Okay, less than negative 7 means go all the way to the left. All right, and then I put a big fat arrow. And then, is negative 7 included in the solution set? Yep, less than or equal to means the endpoint itself is legal, so we color that in. Okay. Number 3. Ooh, oh man. 6 minus 8x is greater than 22. Yeah. So what I like to do is look at this problem and go, okay, 6. Okay, so that means that there's no sign, so it's automatically a positive. And I can switch these now. Now I've got negative 8x plus 6 is greater than 22. Okay, now I can work with this. So now I've got negative 8x plus 6 is greater than 22. I'm going to subtract 6 from both sides of the inequality. And once again, subtraction has no impact on the truth of the inequality statement, so it's still negative 8x is greater than 22 minus 6. That's going to be positive 16. Okay, so now I've got negative 8x is greater than positive 16. I'm going to divide both sides of the inequality by negative 8. That cancels out, leaving me with x. What did I do on both sides? I divided both sides of the inequality by a negative. So the sign, I put SIF. Sign flips, SIF. SIF, SIF. Sign flips. 16 divided by negative 8 is negative 2. So that what that means now is to make this statement true, I can plug in any value of x less than negative 2, and this statement is true. Okay? So what I do is I put 0 in the middle of my number line. I'm going to put negative 2 on the left side. I'm going to circle negative 2. X is less than negative 2, which means I'm going to shade all numbers less than negative 2. And I'm going to put a big old arrow. And put a big, and ask the question, is negative 2 itself invited to the solution set? No, it means less than negative 2, not less than or equal to. Now, moving on to number 4. Once again, 5 minus 7x is less than or equal to negative 23. So I'm going to look at this problem and go, okay, well, there's no symbol in front, so I'm going to put a tiny little positive sign right there. So I'm going to keep the signs the same, just switch them. Keep the symbol negative 7x plus 5 is less than or equal to negative 23. Okay, now I'm going to solve for x. Okay, so now let's subtract 5 from both sides. Subtraction has no impact on this inequality symbol, so we still have negative 7x is less than or equal to negative 28. And now I'm going to divide both sides of the inequality by negative 7. So specifically, negative 7 cancels out with negative 7, leaving me with x. And because I'm dividing both sides by negative 7, divide by negative means I'm going to flip the sign. So this less than or equal to sign becomes a greater than or equal to sign. And now I've got negative 28 divided by negative 7. Negative 28 divided by negative 7 is going to be positive 4. So legally, to satisfy this requirement, x is allowed to be any number greater than or equal to 4 for the left side to be less than or equal to the right side. So now let's make this on a number line. I'm going to plug in 4 on the, I'm going to place 4 on the right side of the number line, circle it, and x is allowed to be any real number greater than or equal to 4. So I'm going to shade to the right, put a big old arrow on it, and then I'm going to shade. There we go. All right, and that's how you do problem number 4. All right, 4 more problems and then we'll call it a day, and the test will be shared with you shortly. Oh, not this. Oh, no. Oh, man. So in this case, the x is on the right side. But are we afraid of this? No. So I'm just going to take a look at the right side and say, hey, I like you better on the left side. So I'm going to rewrite the problem with 15x minus 34 being on the left side. And the inequality symbol is saying that the 15x minus 34 side is greater than, right? Even though it's 11 is less than 15x minus 34, this entire right side is greater than 11. So that's another way to phrase it. I like to ease my anxiety ahead of time. So 15x minus 34 is greater than 11. And now I'm going to treat this like a solve for x kind of problem. So now I'm going to add 34 on both sides. So now I get 15x is greater than 11 plus 34, that'd be 45. Oh, that's nice. So now 15x is greater than 45, which means in order to solve for x, I'm going to divide both sides by positive 15. So now, dividing both sides by positive 15 has no impact on this inequality symbol, so x is greater than 3. I'm going to draw a number line. I'm going to put 0 in the middle. 3 is on the right. X is legally allowed to be any number bigger than 3, so that's my target endpoint. And now, the numbers bigger than 3 go to the right. I'm going to put a big, fat arrow to say I'm going to positive infinity and beyond. And is 3 itself included in the solution set? Sorry, 3, you didn't get invited to this birthday party. I'm sorry. But it was not meant to be. All right. Oh, man. Oh, man. So now I've got 7 minus 2x on the right side. Okay. So now we've got the 7 minus 2x. The symbol is 27 is less than or equal to this, so therefore the side is favoring 7 minus 2x as being bigger, specifically greater than or equal to 27. And yet I'm still going to write this, all right, tiny little positive sign right there. I'm going to write this as negative 2x plus 7 is greater than or equal to 27. And now let's solve for x. So I'm going to subtract 7 from both sides. And now negative 2x is still greater than or equal to 20. And now I'm going to divide both sides of the inequality by negative 2. Wait a minute. I divided both sides by negative 2. So I make a little note to myself. I say this is less than or equal to now, because if I divide by a negative, the sign needs to flip. So therefore, now I've got x isolated, it's now less than or equal to negative 10. Okay, so now I've got x's negative 10 is on the left side of the number line, circle. X is less than or equal to negative 10, which means I'm going to shade to the left. And at the end of the number line, I put a big arrow. Is negative 10 itself invited to the solution set? Yes. So we shade it in. because negative 10 gets invited to the birthday party. I hope there's cake. All right, 2 more, and then the test will be shared with you momentarily. Negative 25 is greater than or equal to negative 3x minus 4. Let's see what you got here. Well, I like my x on the left side, so what I like to do is take this right side. I'm going to rewrite the problem as negative 3x minus 4 on the left side. Okay, not too bad. But remember the side that's greater than, the side that's bigger, rather, is the negative 25. So I'm going to rewrite this problem as negative 3x minus 4 is less than or equal to negative 25. Okay, and now I'm going to solve for x. The x is already on the left side of the left side of it's on the left side of the left part of the equation. So now let's solve for x. So I'm going to add 4 on both sides. So that cancels out. And now I've got negative 3x. Addition has no impact on the inequality symbol, so I'm going to leave it as it is. And negative 25 plus 4, that is negative 21. All right. Negative 3x is less than or equal to negative 21. So now I'm going to divide both sides of the inequality by negative 3. So now x is, ooh, I divided both sides by, that just snuck up on me. If I divide by a negative, the sign needs to flip. So I take a look at this symbol, and this has to be greater than or equal to, right? Negative 21 divided by negative 3 is positive 7. So now x is legally allowed to be any real number as long as it is positive 7 as its endpoint, and we're going to shade all numbers bigger than that. All right, at the end of the number line, I put a big old arrow. Okay. And is 7 itself invited to the solution set birthday party? Ah, he's on the guest list. All right, fill it in. It's legal for x to be equal to 7. Satisfy this inequality statement. I like it. I'm very happy. Okay. All right, just for good measure, negative x plus 19 is greater than 7. So if we solve for x here, there's no number in front. What can I do? Ah, negative 1x plus 19 is greater than 7. So now I'm going to subtract 19 from both sides. So now I get negative 1x is greater than 7 minus 19, that'd be negative 12. And now I'm going to divide both sides of my inequality by negative 1. Ah, I divided both sides by a negative. So the sign needs to flip. So that cancels out. This greater than symbol turns into a less than. And now I get x is less than negative 12 divided by negative 1. That's positive 12. I'm very, very happy. So now I get my number line. X is less than 12. I put 12 on the right side. I'm going to circle my endpoint 12, and x is less than 12. So I shade to the left. And now, at the end of the number line, I put a big old arrow. And is 12 itself invited to the solution set birthday party? Unfortunately not. X is allowed to be less than 12, but not equal to 12. All right, hopefully this was clear. The test will be shared with you momentarily. Good luck.